Okay, hi everyone. So today, as part of the Foundation Mastery Method, we will be talking about integration and Riemann sum. We talk about indefinite integrals. We have a few formulas that we use. We start off with the power rule, which is similar to the power rule we use for derivatives, except here we add the power and divide by the added power. An exception to the power rule is x to the negative 1. So the integral of x to the negative 1 dx is natural log of x. And if you recall, the derivative of natural log of x is 1 over x, and so this is the inverse of that. Similar to derivatives, the integral of e to the x dx is simply e to the power x. However, if we have something of the form e to the power ax, where a is a constant, we take the integral as e to the ax and divide it by that constant. Now we'll do a couple examples to understand these rules. So we start with a simple example, the integral of x to the 7 dx. We notice that this is a simple case where we can use the power rule and n equals 7. So in accordance with the power rule, we get x to the 8 over 8. But we're not done yet. We start by add a integration constant plus c. Now the reason we do this is if we were to take the derivative of x to the 8 over 8 plus c, we notice that the constant equates to 0 and we're left with x to the 7. And so we don't know what this constant is, but we cannot assume that there is no constant since the derivative is going to give us 0. And so we write a general constant c that is a placeholder for any specific constant that might exist. A second example is the integral of 4 to the square root x dx. And the key here is to simplify the power and write it as x to the 1 over 2. Now we can simply apply the power rule, and here n equals 1/2. So we factor out the 4, which is a constant, and we add 1 to the power and divide it by 1 over 2 plus 1. We're left with 4 times x to the 3 over 2 divided by 3 over 2. And we can simplify this by taking the reciprocal of the denominator and multiplying it by the numerator. And lastly, we multiply 4 and 2 to get 8 over 3 x to the 3 over 2. Let's look at another example. So this combines two terms, and to find the integral, we can individually find the integral of each term and simply add them together. So the first term is of the form of the second rule, where we have x to the negative 1. And the second term is of the form e to the ax. So for the first term, we use the second rule and we're left with natural log of x, and the 5 remains constant, so we just multiply it. For the second rule, we factor out the 2 since it's a constant, and we apply rule number 4. And so we have e to the 0.5x divided by 0.5. And then we can simplify the constants to get our final answer, 5 ln x plus 4 e to the 0.5x plus our integration constant. Now let's look at another example. So this may look a little complicated, but the trick here is once again to write the root as a power. So 5e to the x is fairly straightforward. We can apply formula number 3. But for this part, we simply write this as x to the 2 over 3. Since this is the cube root, we get x to the 1 over 3. And then because it's squared, we multiply that by 2 to get x to the power 2 over 3. And so this is n in this case. Now we can use the power rule for the second term and add 1 to the power and divide it by 2 over 3 plus 1. And then we add the integration constant. Similar to example number 2, we can simplify this by reciprocating the denominator and multiplying it by the numerator, and we will be left with 5e to the x plus x to the 5 over 3 over 5 plus c. Let's look at another example. So we notice that this example is in the form of a fraction. But unlike with derivatives, we don't have a quotient rule. What we're going to do is we're going to simplify this by distributing the denominator to every term in the numerator. So we can rewrite it as something like this. And now we can simplify the power of x by subtracting the numerator power from the denominator's power. And so we're left with this equation. And to find the integral of this equation, we can simply use the rules we've mentioned before. So for the first, second, and last term, we can simply use the power rule. And for this term, we can use the natural log rule. And so we're left with 7x to the 7 divided by 7 minus 2x squared over 2 plus natural log of x minus x to the negative 2 plus 1 divided by negative 2 plus 1. And then we have our integration constant. We can further simplify this by canceling out any similar terms to the numerator and denominator, and this is our final answer. Let's look at another problem, which is in the form of a word problem. So this problem tells us that the marginal cost function c prime of q is 24q squared minus 10q plus 5. And then we see that at 2, the value of the cost function is 100. And they want us to find the total cost function. So given c prime, if we want to find c, we can simply find the integral, since we know that integral and derivatives are essentially inverses of each other. And so to find c from c prime, we simply integrate the function that we have. So we find the integral of this function, and to do that we can simply use the power rule as before. And we're left with 24q to the power 3 over 3 minus 10q squared over 2 plus 5q plus an integration constant k. Now, we can't write this as our final answer since we don't know what this constant is. Now, to find the constant, we can use the second piece of information. This tells us that at q equals 2, the value of this function is 100. So if we substitute q equals 2 and equate it to 100, we can isolate k, and we find k equals 46. Now we can plug this back into our function, and we get our final answer to be 8q cubed minus 5q squared plus 5q plus 46. And this is the total cost function.